Welcome back. In our last explainer, we covered how to store data in JavaScript. Now, we need to actually compare it. But here's the thing. In JavaScript, asking if two things are equal can lead to some surprisingly tricky answers. Let's dig in and see why.
Okay, let's start with a classic JavaScript puzzle. How on earth does an empty array, when compared to the Boolean false with a double equals, result in true? Now, you might think this is a bug, but it's not. It's actually the result of a very specific set of rules that, well, can often be pretty confusing. To get to the bottom of this, we need to investigate the operator at the scene of the crime.
And our first suspect is the double equals operator, also known as loose equality. Now, it was designed to be helpful, by comparing values even if their types are different. But this helpfulness, it can cause some really unexpected behavior. The secret weapon behind loose equality is something called type coercion. When the double equals operator sees two different data types, it doesn't just give up and say false. Nope. Instead, it tries to automatically convert one or both of the values to a matching type before it makes the final comparison. So let's see how that works in a simple case. We've got the string 5 and the number 5. JavaScript first spots the type mismatch, and because we're using loose equality, it just goes ahead and coerces that string into a number. The comparison then becomes 5 equals 5, which of course evaluates to true. Seems simple enough, right? Well, this same process is what causes all the weirder results. Yeah, this automatic conversion leads to some truly infamous results. The number 0 is loosely equal to false. An empty string, also loosely equal to false. And just for historical reasons, null and undefined are treated as equal only to each other. You can see how this could quickly become a minefield for bugs in your code. Hey, don't just take my word for it. This unpredictability is why official resources like the Mozilla Developer Network recommend a totally different approach. As they put it, using a comparison that avoids all this type coercion is just plain easier to predict. And that brings us to a much better tool for the job.
So let's bring in our reliable detective, the triple equals operator, or strict equality. This is the operator you're going to want to use pretty much all the time because its main job is to prevent the chaos that type coercion causes.
This side-by-side comparison right here makes the difference crystal clear. With loose equality, the string 5 is equal to the number 5. But with strict equality, that same comparison is false. And why? Because strict equality checks the type first. A string is not a number, case closed. It immediately returns false without even trying to convert anything.
This is exactly why strict equality is your best friend for writing predictable code. It compares both the value and the type. There's no hidden magic, no automatic conversions. With triple equals, 0 is not equal to false, and null is not equal to undefined. What you see is exactly what you get.
Okay, so we're feeling pretty good about our reliable detective, triple equals. Seems like it solves all our problems. But what happens when we introduce a truly unique character into our story? Not a number, or NaN. What do you think this one evaluates to? The answer is false. I know, right? This is a really unique rule in JavaScript. NaN is the only value that is never, ever equal to itself, even with strict equality. Now, this is intentional. It's designed to prevent bad math from being treated as correct. But it does mean that even our reliable detective has a blind spot. And for that, we need to call in a specialist.
For these very specific, tricky edge cases, we call in the specialist, Object.is. This is a more modern JavaScript method that gives us an even more precise, absolute definition of whether two values are the same.
Object.is handles that NaN case perfectly, returning true. It also solves another really subtle edge case. It can tell the difference between +0 and -0, which strict equality actually considers the same. Now, you probably won't need this for most day-to-day coding, but it is absolutely vital for certain kinds of math or low-level operations where that distinction really matters. So we've got 3 different ways to check for equality. The reason they all behave differently is that under the hood, they each use a different comparison algorithm, which is defined in the official JavaScript specification. So let's pull back the curtain and see what's really going on.
Just as you'd expect, loose equality equals what's called the abstract equality algorithm. Strict equality equals the strict equality algorithm. And Object.is uses the same value algorithm. You don't need to go memorize the entire spec, but just knowing these terms exist is super helpful when you're reading documentation or debugging a really tricky comparison bug.
Believe it or not, there's actually a fourth algorithm that's super important for modern JavaScript. It's called SameValueZero. It's almost identical to SameValue, so it handles NaN correctly, but it treats positive and negative zero as the same value. And this behavior is exactly what you need for data structures like map and set, and for methods like Array.includes. And here is a perfect, practical example of why these underlying algorithms actually matter. The older Array.indexOf method uses strict equality, and because NaN is not strictly equal to itself, indexOf can never find it in an array. But the newer Array.includes method uses SameValueZero. Because that algorithm handles NaN correctly, includes finds it, no problem. This difference is a classic source of bugs, and now you know why it happens. This table right here really summarizes all the key differences. When it comes to type coercion between a string and a number, only loose equality equals will say true. When you're comparing NaN to itself, only Object.is gives you the true you'd expect. And for telling the difference between positive and negative zero, Object.is is the only one that treats them as different values. We've investigated the suspects, we've met the detective, and we've even called in the specialist. The case is officially closed. So what's the verdict? Here are the rules you should follow to write clean, predictable, and bug-free code. So here's your new rulebook. First, make triple equals your default choice for basically all comparisons. It's safe, it's predictable, it's what you want. Second, only reach for Object.is when you know you need to handle those specific edge cases, like NaN or signed zeros. And finally, just avoid loose equality, equals. Don't use it unless you have a very specific, intentional reason to let type coercion happen. So there you have it. The whole mystery of JavaScript equality isn't so mysterious after all. It's really just a story of different tools for different jobs, each one with its own set of rules and its own algorithm working behind the scenes. And now that we've totally mastered how to compare data, we are ready to control the flow of our programs. In the next explainer, we're going to dive into loops and iterations, where we'll use these very comparisons to make our code do some really powerful work over and over again. This is Developer Roadmaps. Map your path and build your career.